Hello everyone, I am Dr. VRAO-PHYSICAL. Today I am here with another concept in electrochemistry, that is EMF of a cell, solubility and solubility product of a sparingly soluble salt. Actually we are going to establish a relation between EMF of a cell, solubility and solubility product, right? EMF, solubility and solubility product, that is represented by KSP, right? In the recent years, questions are being asked from integration of 2 or 3 concepts. This is the example for such concept, that is in which EMF of a cell and solubility product of a sparingly soluble salt are these 2 concepts are integrated, and questions are being asked from the integration of these 2 concepts, right? So now let us try to understand how that relation was established, right? To understand the relation between solubility and solubility product and EMF, let us consider a concentration cell. Let us consider a concentration cell. In the previous videos, we had gone through the, had gone through the concentration cells, right? Electrolyte concentration cells and electrode concentration cells. To understand this relation, let us consider a concentration cell, right? That is Ag, silver dipped in silver chloride solution of unknown concentration. This is the salt bridge, and here Ag dipped in AgCl solution of known concentration, right? Known concentration. This is the example for concentration cell. Okay, usually this is cathode, this is anode, and this is cathode. What happens at this is the cell, and what happens at anode and what happens at cathode? Let us see what happens at anode. At anode, usually at anode, oxidation takes place, that is Ag undergoes oxidation, that is Ag solid undergoes oxidation, that is Ag plus, whose concentration is unknown, plus electron. And at cathode, what takes place? At cathode, reduction takes place, that is Ag plus aqueous plus electron gives rise to Ag, right? This is the reduction takes place. This is the reduction that takes place at the cathode, and the net cell reaction is this electron getting cancelled, okay, and Ag, this is Ag solid, this is also cancelled. Then net cell reaction is Ag plus, okay, whose concentration is unknown, Ag aqueous gives rise to Ag plus unknown, that is concentration of Ag. Usually this is the concentration of Ag plus at anode, and this is the concentration of Ag plus ions at cathode. Okay. Now let us calculate the EMF of a EMF of this cell. EMF of a cell is calculated by with the help of Nernst equation, that is E is equal to E cell is equal to E naught cell minus 0.059 by n log concentration. It is a reversible reaction, Okay, it is a reversible reaction. Log concentration of Ag plus, this is the equilibrium constant, and that equilibrium constant, we can write the equilibrium constant for this reaction, that is concentration of Ag plus at anode by concentration of Ag plus at cathode, right. So, this is the Nernst equation. This is the Nernst equation, and this is the equation for EMF of a cell, right. Now, how can we know? Now, we establish the relation between EMF of a cell and solubility product. Now, let us consider the solubility product for AgCl. Solubility product for AgCl. We know that AgCl dissociates as ionization, ionizes as Ag plus Cl minus, and this is the, of course, solubility product is also a type of equilibrium constant. So, Ksp, usually we can write the solubility product for Ag plus as Ag, concentration of Ag plus into concentration of Cl minus, right. This is the solubility product, right. For example, to develop a relation or to establish a relation between EMF of a cell and solubility product. For example, if the solubility product is given in the problem, then how can we calculate concentration of Ag plus? To measure the EMF of a cell, we have to know the concentration of Ag plus at anode and the concentration of Ag plus at cathode, but these concentrations are not known. Okay, these are unknown concentrations. These two are not given in the problem, but they given Ksp of AgCl. How can we get Ag plus concentration from solubility product? Simple, you can get the concentration of Ag plus from this equation, that is Ksp by concentration of Cl minus, that gives the concentration of Ag plus, right. So, from that relation we can substitute the concentration of Ag plus. From this equation we can get the concentration of Ag plus, and this value can be substituted in this equation. Finally, we get the EMF of a cell. So, what is given in the problem? Actually, in the problem they do not provide the concentration values of Ag plus at anode and the concentration of Ag plus at cathode. They do provide the solubility product of electrolyte. So, from which we can derive the concentration of Ag plus ion and concentration of Cl minus ion. Okay. So, this is the relation, this is the way we can relate solubility product and EMF of a cell. So, let us understand the this relation by doing one problem. Okay. This is the problem, that is AgCl cesium chloride 0.1 molar, this is the salt bridge, Cs cesium bromide 10 power minus 3 molar, AgBr solid and Ag. This is the concentration cell. How can I say this is the concentration cell? Because the two electrodes are same. Whenever the two electrodes are same, that is a concentration cell, right. So, calculate the EMF generated and assign correct polarity to each electrode for spontaneous process at 25 degrees centigrade, and given that Ksp solubility product of AgCl is 3 into 10 power minus 10 and solubility product of AgBr is 4 into 10 power minus 13. Right. So, to solve the problem, first we have to write cell reactions, that is reactions takes place at anode and cathode. This is the cell. Usually at anode, what takes place? At anode, oxidation takes place. At anode, oxidation takes place, that is Ag solid undergoes oxidation, that is Ag plus whose concentration is plus electron, and at cathode Ag plus solution at cathode reduction takes place, that is Ag solid. So, these are the reactions takes place. We are very well versed, we can interpret the what is the reaction at anode, what is the reaction at cathode. Okay, and this electron get cancelled, Ag solid get cancelled, and the net cell reaction is Ag plus aqueous, Ag plus aqueous gives rise to, this is a reversible reaction, and Ag plus aqueous. Actually, it is better to write Ag plus concentration at anode and Ag plus concentration at cathode, right. So, EMF of this cell is given by Nernst equation, that is E cell is equal to E naught cell minus 0.059 by N, where N is number of electrons transferred. Here is the one electron involved, one electron transferred. So, concentration of and log K. Log K means equilibrium constant for the net cell reaction. Okay. So, log concentration of equilibrium constant is nothing but concentration of products to concentration of reactants, that is concentration of Ag plus at anode and concentration of Ag plus at cathode, right. So, and from the this is the concentration cell, and from the last videos, that is from the previous videos, we came to know that E naught cell is 0 for concentration cells. So, this is 0 and this equation becomes 0.059. This equation 0.059, we can take it as 0.06 into log concentration of Ag plus anode by concentration of Ag plus at cathode. But to calculate E cell, EMF of the cell, we have to know the concentration of Ag plus at anode and Ag plus at cathode. How can we get the concentration of Ag plus anode and Ag plus cathode? They gave that solubility product. They gave the solubility product values, that is KSP, that is solubility product of AgCl. First we calculate the Ag plus concentration at anode. What is the solubility product at anode? AgCl, KSP is KSP for AgCl is concentration of Ag plus into concentration of Cl minus. Okay. So, KSP, what is KSP? 3 into 10 power minus 10 into concentration of Ag plus into concentration of Cl minus. So, they gave the concentration of Cl minus, that is 0.1 molar. We can take Cl minus and concentration as 0.1, right. This is 0.1. Therefore, concentration of Ag plus is equal to 3 into 10 power minus 10 by 0.1, and this comes out to be 3 into 10 power minus 9 concentration of Ag plus, right, at anode. And now we shall we calculate concentration of Ag plus at cathode, that is solubility product at cathode. AgBr is given by 4 into 10 power minus 13, that is KSP of AgBr is concentration of Ag plus into concentration of Br minus. Okay, this is 4 into 10 power minus 13 into concentration of Ag plus at cathode. Concentration of Br minus is 10 power minus 13, so 10 power minus 3. So, therefore, concentration of Ag plus at cathode is 4 into 10 power minus 13 by 10 power minus 3, that is which comes out to be 4 into 10 power minus 10 Ag plus at cathode. Substitute these two values in this equation, that is E cell is equal to minus 0.06 log concentration of Ag plus at anode is 3 into 10 power minus 9 by concentration of Ag plus at cathode is 4 into 10 power minus 10. Okay. So, minus this is minus 0.06, 3 by 4, 3 by 4 means 75%, that is 0.75, 0.75 and there is a 110, 0.75 into 10, that is log 7.5, that is log 7.5. So, this is minus 0.06 log 7.5. How can we get the log 7.5 value without using logarithm book? We know that log 7 value is 0.84. Okay, then how can we get 7.5, that is 0.5, there is an increase of 0.5. So, just you add, to get the log 7.5 value, just add 0.032. Actually log 7 value is 0.84. Okay, so you just add 0.03 to log 7 value, that is 0.87. Okay, so log 7.5 is 0.87. You just 0.87 on multiplication, which comes out to be minus 0.05. That is E cell is negative. E cell is negative. So, E cell is in relation with the delta G, and they ask to find out the polarity, assign correct polarity to each electrode for spontaneous process. Actually, when we get E cell value negative, then delta G becomes positive, because delta G is in relation with the E cell by the equation delta G is equal to minus NF E cell. So, E cell comes out to be negative, so delta G becomes positive. Delta G is positive, that is a non-spontaneous process, right. So, for delta G becomes negative, what we do, you change the polarity of the electrodes. That means you invert the cell reaction, that is you use this on this side and this is on that side. You just invert the polarity, you just change the electrodes, right, so that you get E cell value is positive. When E cell positive, delta G becomes negative. So, delta G negative means that is a spontaneous process. Okay. In this way, we can understand, we can do more complicated problems. So, finally, what we need to know is integration of these two concepts, that is solubility product and EMF of SL. I hope you all understand this lecture. If you really like this video, you please extend your support by like, share, comment. Thank you. Thank you for watching. Okay, if you really like this video, please extend your support by like, share, comment, and I wish you all Happy New Year to you all. I wish all of you, you have a bright future in the coming year. I wish all of you, please make the 2023 year as a colorful year in your life. Thank you. Thank you for watching.